So a couple of things I wanted to accomplish with this short. First of all, I wanted to try the new transformer. I have the transformer hooked up. I've reversed the transformer and used the two primary windings as the secondary in series 80. I'm measuring about 290 volts DC. So this leads me to believe that when I do a full wave doubler, we should get something just under 600 volts to work with. So that should allow us to do a 0 to 450 volt power supply. Both of these transistors are really not designed for linear service. They're made for switching service. We are using them in the linear mode. I've increased the Zehners to the point where we can do 0 to 250 volts DC. So I added a couple of Zehners to get there. I had to reduce the series resistor from 27K down to around 20K for that Zehner stack, 253. At 42 milliamps, that's going to put some dissipation into that bipolar pass device, of course, under 10 watts, but still significant for this tiny heatsink. Just looking at this, it's fairly easy to figure out that this could probably power something like a Paraset or a regenerative receiver or a small QRP transmitter without much trouble at all. Let's bring it up with this 2000 ohm load. It should draw considerably more current. Okay, the current limit's starting to cut in. Full blast, it's 126, it's brought it back to, and 62 milliamps. Let this cook for a minute. Considering the dissipation of the transistor, however, it's only about half rating, but I think a 50% rating is a good idea when we're using these things in linear mode. Probably a conservative way of using these switching transistors as linear devices. Again, this is an all bipolar situation we've got going. See if we get thermal runaway. This would be a nice demonstration of a thermal runaway situation where the transistor destroys itself. Looks like the current is actually going down. Okay, we've been running for about 5 minutes. Key down. Now let's feel the heat sink. Oh, it's warm. I can still keep my hand on it, but it's getting hot. Ow. Okay, I guess we went to the limit on this little heat sink, but I'm very surprised that it didn't blow up the transistor, but it didn't. Now maybe the fact that I had the constant current limit and the pass transistor in the same heatsink worked in my favor, and that actually improved the situation and kept it out of thermal runaway. So in the comments, what do you think? This is the poor man's regulator.